On this video, I'm going to show you how to deal with the capacitors, and mainly if you have more than capacitor. So remember that when you have a capacitor, so let's say that I have this particular circuit where I have three capacitors. All right, so here is the circuit. So I have a battery here, and I'm going to have first I'm going to have two capacitors in series, and then another capacitor is going to be in parallel with those two here. So let me give you some numbers. So let's say this is 6 volts, and this capacitor is 3 microfarad, and this one is a 6 microfarad, and this one is say 5 microfarad. So the question is, uh, so these are connected to a battery 6 volts, and the question might be that what is the charge and the voltage on each one of these capacitors is the question. All right, so how do we deal with them? All right, so what we need to do is we just need to analyze this particular circuit in terms of charges and voltage. Now, when it comes to a capacitor, you should know that the capacitance C is given by the charge Q divided by the voltage between the plates. Anyway, so the capacitance is Q over V, or you can also write the charge on capacitor plates. Let's say you have some positive on one side, negative on the other side, can be written as C times V, where C is the capacitance, V is of course the potential difference between the plates. So that's a basic idea about capacitors. And then you also need to know that when capacitors are connected in parallel, how do we combine them? So if you have two capacitors, let's say I have one like this, another one like that, two of them here. So this is, they are connected in parallel. So let's say this is C1, this is C2. So if I want to find an equivalent capacitance for these two capacitors, let's say I like to make it into a single capacitor C. Now, when they are connected in parallel, the C is basically equal to C1 plus C2. So when capacitors are in parallel, all you have to do is just add the capacitors to get the equivalent capacitance. On the other hand, if they are in series, what do we do? So here is one capacitor, and I have another capacitor in series. So let's say this is C1, this is C2. So now the question is, how do we combine these two? All right. So in this case, the way we find this equivalent capacitance is to use this particular formula. 1 over C is 1 over C1 plus 1 over C2. So that's the way you had to find the equivalent capacitance. Now, one thing you have to be careful when you do this, when you do 1 over C1 plus 1 over C2, what you get is 1 over C, but then you need to flip it to get the C anyway. And if you just go through the algebra a little bit here, what you will see is the common denominator is C1, C2. And then if you do this, C1, you will end up with C2 plus C1 on the top, and then I had 1 over C. So now if I flip it, C is equal to basically C1, C2 divided by C2 plus C1 is same as C1 plus C2 anyway. So this is a simple expression, especially when you have only two capacitors. So when they're in series, you can also find it using this expression here. So this one basically says you take the two capacitance values, just multiply them, and then you divide by the sum. Will give you the equivalent capacitance. Or you can do this one, of course, 1 over C is 1 over C1 plus 1 over C2. But when you do that, don't forget, at the end, you're supposed to flip it to get the C anyway. So that's the basic stuff you need to know about this. So let's come back to this particular problem here and see how we deal with this. So the first thing is, look at the circuit and let's see whether we can figure out the voltage. So for any particular capacitor, if we know the capacitance and if we know the voltage, you can find the charge. All right. Okay, so let's look at this carefully and let's concentrate on the 5 microfarad capacitor here. And if we follow one side, this side goes all the way to the plus side here. So, and then if you follow the other side, that one comes back all the way to the negative side. So if you see that, that means the voltage for that should be 6 volts. All right. In other words, the 5 microfarad is in parallel with the 6 volt battery. So the voltage should be 6 volts. So that means we can easily find the charge on this capacitor. All right, so for the charge, I'm going to use a different color, let's say purple or something. So the charge on this one will be CV. All right, so as you multiply C and V, C is of course 5 micro, and you multiply that by the 6. So you end up with basically 6 times 5 is 30 microcoulomb is the charge on this capacitor here. All right, so you can easily do that. If you know the voltage, you can do that. But that now the question is, how do we find the charge on these two capacitors, 3 and 6? All right, now right now we don't know that, because the reason for that is we don't know the voltage right now. All right, but at least you should know, since these two are in series, and they both should have the same charge. All right, because you know that when the positive charge on this side becomes, this side is positively charged, this become negatively charged, this become positive and negative. So when the charges moves through the series circuit here, the plates must get the same charge. Okay, so if I put 2 plus over there, I put 2 minus, another plus, another minus, so they have the same charge, but we don't know how much it is. Okay, so what we could do is, the first thing we should do is to combine these two capacitors into a single capacitor. All right, so we're going to combine these two into a single capacitor. So I'm going to make another diagram here, and this will be a single capacitor of those two. And then of course we have the other one on this side here, which is 5 microfarad. We dealt with that already. Now if I combine these two, I'm going to get the single one. So how much is going to be that the single one, or the equivalent for 6 and 3? Well, you can find that either using this formula here, or I told you about this formula. So either one you like to use either one you like, and you will see. So I'll use this one here. So if you do that, you will find C is equal to C1, C2, so 6 times 3 divided by 6 plus 3, which is 9. So that'll be 18 over 9, that'll be 2 microfarad. So this capacitor is just 2 microfarad. So what I have done is I have combined 3 and 6 into a single capacitor. They are in series. Okay, so now what I could do is, if you look at this circuit now, here is the 6-volt battery. And now if you look at the 2 microfarad, now you can see it is connected to the 6-volt directly. All right, so that means if I follow this side, you see that drive goes there, this side comes over there. So now you see this must get 6-volt anyway. All right, because the 2 microfarad capacitor is directly connected to the 6-volt battery. So we know the voltage for that. So let's find the charge on that one now. Okay, so if I find the charge on this one, I will use just CV. So C is of course 2 micro multiplied by 6. So that'll be 12 microcoulomb. All right. Okay, so that means we know that this is equivalent to these two in series. So we have 12 microcoulomb charge on this capacitor. That means the charge on this one is also 12 microcoulomb. So the charge on this one should be also 12 microcoulomb, and also the charge on this one to be also 12 microcoulomb. This is because when capacitors are in series, they will have the same charge as that of the equivalent capacitor. So they all have the same charge here. All right. So if I go back to this expression you see here, let's say that C1 has plus plus minus minus, and then this might be a plus plus minus minus. So this also has the same charge, plus plus minus minus. So we know that the charges are the same anyway. So when you have in series. Okay, so that means we got the charge. So now actually what you could do is if you go back to this, you know the charge and you know the capacitance, so you can find the voltage. All right. So let me go back to my red color. So let me find the voltage for this one. So the voltage will be Q divided by C. From this formula we have C is Q over V. So V will be Q over C. So let's put the Q, which is 12 micro, divided by the C, which is 3 on that side. So this will be basically 4. Well, this is also 3 microfarad anyway. So let's put the micro. So micro cancels out. You end up with 4 volt. So 4 volt is the voltage on this capacitor here. Likewise, if you do the voltage on this one, it will be, again, I'm going to use Q over C. Q will be, I will use 12 micro for that, divided by the capacitance is 6 micro. So you get 2 volt for that. Okay, so what we are getting is we are getting 4 volt for this one. So this gets 4 volts there, and the other one gets 2 volts. And that makes sense. You can see that 4 plus 2 makes 6. So that's the way here. So basically what we have done is we have figured out the charge and the voltage on each one of these capacitors. All right. So just to recap, you see on the 5 microfarad, the voltage will be 6 volt. On the 3 microfarad, the voltage will be 4 volts and the charge will be 12 microcoulomb. And on the 6 microfarad here, the voltage will be 2 volts and the charge will be 12 microcoulomb. Of course, the charge on the 5 microfarad will be 30 microcoulomb. So that's the way you deal with these capacitor problems.